Bum bum bum. Yo, what up? Yo, what's going on, everybody? How's it going? Oh no, wrong one. Dang it. Let's go. Okay, let's see if we can do this. So it goes what? For I in through 15. Meter. Check. That worked. Let's go. Okay, then let's go. Let's do this one more time. We're gonna do this. Touch. Chapter 7. Exercise. I. How do you do a loop? Okay, let's try this. Okay, let's say for I in 1 to 15, right, we're going to do, and then we're going to say is make dir, we'll make dir for chapter 7, exercise I, right? Then that's echo chapter 7 exercise I slash No, we don't want to echo. We don't want to echo. Can we just like pipe this to, or oh, I didn't quote. Oh shoot. Huh. That didn't work either. You take this, throw that there. What happens? This is so frustrating. Does that work? So how do you do these indents? That's I don't know. Huh. Whatever. Let's just do this. Ah, okay. We want to do make dir and then we'll just leave it at that. We'll go, we'll do this again, but we'll say syntax is annoying. And we want to touch. Alright, boom, let's go. Do that. No way I got the same hat on right now? No way. Nice. What's up? The one day I broke this out of the closet after like a year. Hey Omar, how's it going? Hey Slow. Ray, how's it going? Sath, how's it going? Yo, what's going on, my boy? Alright, you guys. Welcome into the stream today. Appreciate you being here. We're gonna jump back into C Programming: A Modern Approach, second edition today, to the 7th chapter, back at the end of it. We're going to be working on these exercises. Hopefully we can complete these 15 exercises, and yeah, that'll be what we're going to work on for today. Should be a fun stream to get some practice working with types in C. Definitely need to get some exposure to working with more types, beyond just the int and float type. So yeah, I appreciate you guys being here. Why C programming? I want to be a better programmer. So what do you do when you want to be a better programmer? You learn probably C or C++. From what I've come to from here. Okay. Give the decimal value of each of the following integer constants. Okay. So these are integer constants. So let's go and look at our integer constants here. Numbers that appear in the text of a program, not numbers that are read, written, or computed. C allows integer constants to be written in base 10, base 8, or hexadecimal base 16. So this is octal number. It's going to be this first one because it begins with a 0, but it's not a 0x, meaning it's not a hex number. So it's an octal number. Must begin with a 0. Example is this. Okay, so 077, which is the power of 8. Okay, so let me get out my whiteboard here. So if we have 077, 077, no, 077, 0 is double 7. Now with these octal numbers, I am going to go back actually because I don't really remember a ton. Did you read it left to right or right to left? Which is the order of magnitude here. Integer constants here. Okay, octal. Right here. So octal numbers represent the decimal integer. Okay, so this is 8 to the 2. This is 8 to the 1. This is 8 to the 0. So it's 0. It goes this way, like we do in bits. Okay. Got you. So with the most significant bit up front here. So what this will be is 8 squared. What is it, plus 0 or times? Times. So you sum the values here, right? But you multiply the value against here, right? So it'll be 8 times 0. So this is 0 plus 8 to the power of 1. Oh, I'm sorry. Yeah, sorry. 0 times 0 is 0. 8 to the power of 1, which is just going to be 8, right? Now this is going to be times 7. And then, oh, whoops. Yeah, so 8 to the power of 0, 8 to the power of 0 is 1 plus, so this will be plus 7, right? So 8 times 7, what, 56? Is that right? I think so. Yeah, and then plus another 7 on top of that bad boy. Right. And our answer would be, let's do some simple math here. Go up to 9, 4, 63. Is that correct? Is that 63 is this first one? Is that right? Do we agree? I don't know. Okay, let's think about it one more time. So this is 8 to the 0, which is just 1, times 7, which is 7. 8 to the 1, which is 8, times 7, which is 56. 8 squared, 64 times 0, which is 0. It's not included, so it's just this here. I think that's our answer. 0.77 octal in integer, or in decimal, is 63. Let's look it up. Let's go. Got it. Okay. Next one. So we got a hex number here of 0x77. Right, so hex is base 16. So this is 16 to the 0, 16 to the 1, right? Right? I think so. If I remember right. Anybody gonna correct me? So anything to the 0 power is 1. Anything to the first power is itself, so 16. So this would be 16 times 7 plus 7. 119. Is that right? Oh boy, anybody got another answer? I don't know. I've never really done this before, so I could be wrong. Okay. Let's look it up. 0x77 and 119. Let's go. Let's go. Okay. Next, we have 0x A, B, C. Right? So this is 10, or this is 16 to the 10, 16 to the 11, and 16 to the 12. Right? So may need to do a little bit of more math here. Let me get a calculator out. Does most. We could write a script for it, but I don't really feel like it. We're gonna do some coding anyways later. 16 to the power of 10. Oh, that's right. I remember the lecture, me reading about that in there's a program, I remember reading about it. Oh, come on. I'm not reading about it. Watching a video of a guy giving a lecture and he used it. What was it? It was, it has a different name in Mac, a slightly different name. Let me go to what my videos I've recently watched.
Is the other thing, this kind of fear of
code you've
and see.
There's definitely an episode 2.
The other thing, and this is an important feature, is any address is defined to be the sort of the word size of the machine. When they say it's a 64-bit.
I guess I'm trolling. Okay. Okay, so we can just do this. Echo 16 to the power of 10 times, or hold on, we'll do 16 to the power of 10 times wait, oh, I'm dumb. I'm sorry. It's not that. It's right. It's 16 to the power of 0, 1, and 2, and these are going to be multiplied by A, B, and C, which is going to be 10, 11, and 12. So 16 to the power of 2 times 10 plus 16 to the power of 1, right? We know what that is, times 11 plus 16 to the power of 0, which we know, whatever, I'll just do it, times 12 here. Then we do this, and when we pipe do this, get 2748. So 0x A B C hexadecimal and decimal is 2748. All right. Right? 0x A B C. $27.48. Let's go. All right, that's number 1 done. Number 2, moving on. Let's go. Hello, everybody. What you guys doing? Well, let me know what you're working on. Okay. Number 2. Which of the following are not legal constants in C? Classify each legal constant as either integer or floating point. Okay, so 0, 1, 0 e to the second, or e exponential, or scientific E, so just move E the decimal 2 values to the right, making this 1,000. I'm pretty sure this is valid. Well, this is like, this might be, I don't know, maybe the the leading 0 might be ignored, or it might be read as a octal number. But by having this E here, I don't think it will be read as an octal number, because the 0 will just be dropped, and this will be set to be 1,000.
You're not that guy, pal. Trust me. You're not that guy. Okay.
Hey, thanks so much for the
Absolutely.
sub. Appreciate you so much, my guy. You're awesome. Welcome, welcome. My hat's like puffing up on top of my head because my hair is so puffy. Look, it's crazy. Okay. What do you guys think for A? 010E2, right? Would this be read as an octal number because of the leading 0, or because we have an E in here for scientific notation, this 0 would be dropped and be read as 1,000? Now, because we have an E in here, does that make it floating point as well? Like, it'll have a decimal that is, placed, and then a 0 that comes afterwards. These are good questions to have. Because we're having these questions now and learning from them, we won't like really forget them later on because we're like going through this thought process now. So let's go back into our notes here. Hexadecimal constants, right? Yo, what's going on, dude? Welcome in. Welcome back in to the study session here. So e to the plus 5. So that's no different than, so honestly, I'm just a little tripped up with the leading 0. What is this, Python? Is this allowed in C? I don't even know. I mean, let's try some stuff. Let's go like, right, and let's say we have, I'm guessing this is going to be a float. We'll find out. Whoops. Okay, let's go GCC -O, chapter 7 exercise EXE. Oh, hold on. Hold on. Let's go GCC -0 exercise 2 EXE. Chapter 7 exercise C. There. Oh, my bad. What am I doing? I haven't done this in a while. It's been a couple of days. Right. And then let's do /. Okay, so we do get it in 1,000. Now, if we change this to a D, what happens? Got you. because this is a float. Now, if we change this, though, to an int, can this read as an int? Yes, it can. Well, let's see. Let's do this. Let's just put it into here. Well, no, because I don't know. Let's go back. Constants. Decimal. So there aren't any integer constants, are only of decimal, octal, and hexadecimal. That makes sense. Legal constant as either integer or floating point. So obviously I think A is going to be legal. 010E2 is legal and is an I think it works with either interpretation here. Format specifies type int, but the argument has type double. Okay, so it is a float. And you do an implicit conversion by saying int and then forcing it to convert into here. No, I defined it as an int, which implicitly converted it to an int to match, which we could have lost decimal placings, right? Like if this was a float double. Okay, cool. So then we can do printf 2%. This one is also going to be a float. We'll just copy this other one down. Right. And then this one is going to be 32.1 e to the positive 5. Right. So this should compile, which it does. Now if I do a D here, it does not. 32.1 E plus 5 is legal and is a float of type. Cool. So then next is 0790. So this has all the specifications of an, no, octal numbers go up to 0 through 7. So this is not an octal number because we have a 9 here. Right. So this is just an integer of 790. 0790 is legal and is an integer in decimal format. Um, 100,000 with an underscore. Now, does this work in C? I don't know. Let's find out. So 100,000 underscore. Can we print this value? No. Doesn't look like it. What if we define it? Let's do, it should be able to fit within an int. No, ints are up to go to 65,000, right? So this should be a long num is equal to 100,000. No, you can't even do underscores like that in C. Okay. Is not legal. This is not Python. All right, cool. And then E. Right, this is legal. 3.978 E to the -2 is legal and is a floating point type double. So we can do here and give 3.97 E 8 E to the -2. This would be F here. Okay. All right, let's get some feedback here. Here's some clean feedback. Your answer, legal, and is a float of type double. Correct. It is legal, but the reasoning needs a tweak. 010 is an octal number. Octal integer literal. Value of 8 equals decimal. Okay. 010E becomes this. Okay, so whoops. So is legal. Is a double. It is a double, but it's not a float. Default floating literals are double. So is an octal number, which equals to 8, and is legal with type double. This is legal and is a float, or is it type double? So this is legal. And is a type double. This one's not legal. Anything starting with 0 is parsed as octal. Oh, okay, so you can't, it doesn't automatically drop it. Well, I didn't print it. I probably should have printed it. That would have been nice for me to do. That would have given me my answer, right? Right. This is not legal. So this is an octal number, which equals to, let's do the math here. So 0 is being applied to the 1, so we're not including that. 9 is being applied to 8 to the power of 1. So 9 times 8 plus, right, okay, so if we do, let's do this, 9 times 8 to the power of no, it's 9 to the base power of 2 plus 7 times 8 to the power of no, I'm dumb. It's 9 to the 1. 2. 520. So let's look up here we go. Well, it's not valid because 9's in it, because it only goes to 0 to 7. So why are we even computing this? Yeah, okay, that makes sense. Okay, so is not a valid octal number due to the because octal numbers only have values 0 through 9 in 0 through 7 in there, and yeah. This is not legal. I'm not allowed. It ends a floating point of type double. See, floating point of type double. Oh, type double. A floating point. Double. Okay, here we go. Let's get some feedback here on my answers. All right. Looks good. Nice. Awesome. Cool. All right. Cool. That's number 2. Let's move on. Number 3. What's going on, James? How's it going, Andrew? Thanks for coming in. Welcome, welcome, welcome. Okay, number 3. Which of the following are legal types in C? Okay, A, short, unsigned, int. Okay, let's think about this. So we have a short, unsigned integer. So a short positive number. It sounds solid to me. I think this is legal. Short unsigned int is a legal type in C with values that are integers with small positive integers. Smallish. Right? Kind of. Let's put it to the test here. Oh, int function. Let's put it to the test here with a call to actually declare it. Let's say short unsigned int is num, and that is equal to 5. Let's print f to, do we use %d for all, even though it's still an integer, with all this additional stuff? Let's find out. Let's open a terminal here and run gcc-o. Here we'll do _exe on this, run. What did I do wrong? Initial undefines. Oh, in the wrong terminal. My bad. Alright, it worked. No errors. Okay, cool. I think that's okay. Let's try our next one. B. Short float. A float always has 32 bits reserved for it, right? So I don't think that this is valid. Let's see. Let's call a short float to num equals to 5.0f. Let's call a printf to num, insert a float here. See what happens. Short float is invalid. Format specifies type double, but the type has type short. Oh, so shorts you specify with h. For a short integer, h in front. How do you remember all these? Well, that will force it to print in that format, right? Now let's ask here, is when printing shorts, do you really need the short ints? No, you don't really need the %HD when printing a short, but you should use it. The correct specifier for short is %HD. In almost in all real cases, is promoted to a type of int for the print. Compiler warnings like, well, okay, we need to remember that. So this is not legal. C. Long double. I'm pretty sure this is not legal as well. Let's change this to a long double. Oh, a long double is allowed. So that's what, okay, so that's how you get the extra precision in from double, is with long double. So long double is legal, a legal type in C. Okay, cool. So then this would be long float. Or double float, right? Yeah. Okay. Next up, let's go ahead and do D. Unsigned long. So is a legal type in C, right? With values that are large. With a large value range. Positive. Right. So this would be unsigned long. Right, so unsigned long would be this. 5. Beautiful. Nice. Perfect. So short int would have HD here. Okay. Let's get some feedback on these answers here. Short unsigned int is a legal type in C with values that are smallish positive integers. Correct. Range is 0 to at least 65,535, typically on 16-bit short systems. But the C standard guarantees at least 16 bits. If it's signed, has a minimum range of this. So correspondingly, unsigned is this. Half the values become reserved for the negative, right? We lose one order of magnitude for a bit. Your description is fine. It's needed for, okay, cool. Short flow is not legal is correct. Nice. Long double, correct. Is the largest floating point type. Unsigned long is legal, correct. Nice. All right, number 4. Let's keep it pushing. You guys are enjoying the practice problems here in C, and if you're solving them with me, let me know. I'd really appreciate that. You guys are awesome. Awesome. You guys could like the stream and subscribe and follow along. I stream almost every single day. I am a human biologist and chemist. I have a degree in those fields, and I've been working as a chemist for about 4 years now. Almost 4 years. Cool. Let's keep on pushing. I've been teaching myself how to code for a little over a year and a half, though, trying to get better and challenge ourselves. Okay. If C is a variable of type char, which of the following statements is illegal? So we'll say this. C char C, right? We'll say A I plus equals C. So this results, this is legal. Right, so hold on, we'll say this. We'll do I as type. So this is legal. The ASCII value of C will be added to int I. B. C equals 2 times C minus 1. I don't see why.
You're not that guy, pal. Trust me.
Hey, thanks so much.
You're not that guy.
Thank you.
Absolutely.
Appreciate you so much for the subscribe. Let me go. Hold on. What was that? That was a different sound than normal, wasn't it? What was that different sound? I missed it. Let me go to my dashboard thing here. Come on. Come on. What's going on, isn't it? Load. Hello. What the heck? Oh, no worries. Thank you so much. That's probably what it was. We probably hit a goal or something. I wanted to see what it was. Thanks so much. Abdo Blade. Appreciate you for coming in. Welcome. Let me know more about you. Okay. B. This is legal, I'm pretty sure, right? C equals to 2 times C less than 1. Right, this is legal. More arithmetic on C, which is a char. Really type, really, which is really type int. So C put char. So this will print the char to the screen. So this is legal. A quick print of C to the terminal. Quick print of the value of C to the terminal. Whereas printf C is illegal. We need a format specifier and proper argument notation. Okay, let's get some feedback on this guy. Mostly correct though. Okay, legal. The ASCII value of C will be added to int I. Char is promoted to int in arithmetic expressions. This works whether a char is signed or unsigned in your system implementation defined. The value of C is treated as an integer is added to I. Correct that it's legal, but with one important caveat. You should mention C is promoted to type int during the arithmetic. After the computation, the result is converted back into a char when stored into C. This may cause overflow if the result is outside the char range. Okay, so because C is still a char, you have strict char ranges to those ASCII values, but you really have a type int just with stricter ranges to map to ASCII characters. Okay, so more arithmetic on C, which is promoted to int during the expression, then is converted back to char when saving in variable C, when updating C. Careful, overflow may occur if the new value of char C does not is not within the range -128 to 127. For signed char. Oh, sorry, my bad. Okay. So put char prints the character associated with the integer value of the character associated with the corresponding integer. Printf expects the first argument to be const char star, a string literal or a pointer to a character array. Passing a plain char will be treated as a pointer value, which is invalid and unsafe. So the issue isn't only missing from the format specifier, the type of the first argument is wrong. Okay. Hey Ray, I see you with the 4040. Yeah, 4040 subs. Let's go. We're almost at 4100. My goal was 5K by the end of 2025. We started kind of really taking streaming seriously at the end of 2024, beginning of 2025, and my goal was to try to hit 5K in 1 year. So hopefully maybe we can hit that by the end of December here. We have a couple more weeks to gain 900 subs. I don't know, how to crank out some more videos or something. Really try to push for some more shorts. Hey, Cello. How's it going? Okay. 5. Which one of the following is not a legal way to write the number 65? So A, capital A, I believe is 65. In ASCII. So this is B, which is 0B 1 1 2 3 4 5 1. Right, so this is a binary number, right? Where we're including that order of magnitude. So 2 to the power of 0. 1. So this is 2, 3, 4, 5, 6, 7. Right? 7. I don't think this is right. This would be 128 plus 1, which would be 129, no? Is that not even 65, or am I reading this wrong? Maybe I'm wrong. Let's see here. Let's ask. Let's get some more feedback on this guy. 0B10000001. Is this binary, and is it the number 129? $64. Oh, I was one off. 0, 1, 2, 3, 4, 5, 6. My bad. Trolling. Sorry, guys. It is 64. So it's 2 to the power of 6, which is 64, plus 1, which is 65. So this is illegal. 64 plus 1 equals to 65. Quote A is equal to 65. Cool. Assume that the character set is ASCII, yeah, right. So we have an octal number here where we have our base is 8. So 8 to the power of 0 is 1. 1. So we have 1. 8 to the power, we're not including that one, to the power of 2, or power of 1, power of 2. So 8 times 8 is 64, plus 1 is 65. That is also an octal number. This is 64 plus 1. And then we have a hex number here, which is base 16. So 16 to the power of 0 is 1. So we're going to include that one. And then times 1 is 1. And then we have 16 to the power of 2 times 4, right? Hmm. 16. What's going on with my internet? Sorry, 16 to the power of 1 times 4. Why do I keep skipping? It's not, it just goes increments by 1. So this is power of 0, power of 1. So 16 to the power of 1, which is 16, times 4, which is 64, plus 1, which is 65. It's legal. It's 64 plus 1 is equals to 65. I'll do this. I'll do 16 to the power of 1 times 4 plus 1. Cool. Let's get some feedback on this one. Did I really not do it? Okay, yeah. This is the literal character in ASCII is 61, 64, good. It's octal, not binary. Yeah, we know that. That's what we did. Sixteen to the power of 0 times 1. Oh, whoops. Sorry. I'm just missing that there. Yeah. Cool. Got that one right. Moving on. We're doing pretty good here. Number 6. Being a biochemist, why do you want to learn C programming? I'm just wanting to, get better at in general. I really feel like honestly, with the way that things are going, with the way that technology is developing, um, if you're a physical scientist that doesn't know programming within the next like 20 years, or at least how to like use computers to, model, to predict, to solve, to automate, I think you're going to get left behind. I think the world's going to move past, the Microsoft Office, and into like, it's just going to ramp up, I think. Okay, cool. 6. For each of the following items of data, specify which one of the types, char, short, int, or long, is the smallest one guaranteed to be large enough to store the item. The smallest one guaranteed to be large enough to store the item. Okay. So for A, right, days in a month, right, I mean, we could do, what, short int? It's only like maximum 31. Short unsigned int. Oh, specify which one of the types, char, short, int, or long. So we don't have to do signed or unsigned. So I think this would be a short. Days in a year. Right, 365. Oh, we have char. This should be a short. I forgot. The char would fit even smaller units of data of integers, right? We can use char to even go beyond short or even further down. Because char is only up to, that negative, what, 128 to 127. So I think that's our answer for that one. Let's go see here. So minutes in a day. How many minutes are in a day? It's not something I know off the top of my head. 60 minutes an hour times 24 hours. 1440. What? Probably just an int. What are the short value ranges? Let's look up in our notes. Int's huge. So this will probably be short. So minutes in a day be short. And then seconds. So what? There's 60 seconds in a day. Or sorry, 60 seconds in a day. There's 60 seconds in a minute times 60 minutes. 24. Ooh, I did divide. So 60 squared times 24. 86,400. This one's going to be an int. Yeah, it can't be a short int. Okay, let's get some feedback here. Okay, given short. Oh, we have a long too. I would never use a long. All right, I don't need 9 million minutes. Second. Short. Char, int, or long. I had to deduce the smallest capable of holding so days in a month. Char, nice. So days in a year would be short. Max days is 366 with leap year. Char max is 127. A short is usually 16 bits. Assign short goes to that. Short works perfectly. Minutes in a day, 1440. So a short works fine for that one. Seconds in a day, int is correct. So we did not use long at all on this one. Tricky, trying to trick us. Nah, not today, not today. Okay, and king, not today. All right, cool. Number 7. Keep it pushing, boys. Keep it pushing. Wise people have said, if you know C, you can build anything. Hopefully that'll be true when we get through some of these books. I'm really excited to kind of like, I don't know, I really want to, like, in Python, I kind of like, I felt that like awakening, being able to like build certain things that just came to my mind, like, you know, for mathematics or for data organization or for internet parsing or something, like, you know, whatever, like web page parsing or something. But like, I didn't really understand how to like manipulate the computer at all, or understand what was going on with the computer and write programs with that kind of mindset. And so I'm excited to be able to kind of see if I can unlock that power at the end of these books. Obviously, we need to put this learning into practice once we get through. We haven't gotten to like memory and arrays and stuff yet, so um, I haven't really been able to like build like a project yet, because I haven't really gotten to be able to like, you know, store information rather than just simple print scripts or whatever. So once we kind of get a little bit more tools under our belt, I will probably open up like a side project as we work through this, you know, in C, doing something for sure. Okay, number 7. For each of the following character escapes, give the equivalent octal escape. Assume that the character set is ASCII. You may wish to consult Appendix E, which lists the numerical codes for ASCII characters. Okay, so we need to understand what these characters are in their ASCII chart. So let's look up an ASCII chart. Let's go to images here. Okay. That's a terrible chart. Okay, so here's some stuff here. Vertical tab, backspace. So let's go to our notes for. Did I not screenshot? Oh, here it is. Yeah, backspace. So backspace is decimal 8. Okay. So backslash B. So this is a backslash B, which is the backspace, has decimal is equal to 8. The octal is equal to 0. 1, 0? So it would be 0 times 8 to the power of 0. So 0 times 1 is 0. And then we do 1 times 8 to the power of 1, which is 8, which is 8. So let's look up 010 octal to decimal. See if we got that right. Eight. Perfect. Okay, \n, which is the new line, which we know. Is it line feed? Is line feed? It's not form feed, that's \f. I'm guessing line feed. Yes. So line feed is decimal 10. \n, which is the line feed, right, in decimal is equal to 10. In octal is equal to 0, 1, 2. So 0, 1, 2 octal to decimal should be 10, right? Let's freaking go. Look at us converting decimal octal. Let's go. All right, return. Is that carriage feed? Carriage return. Gotta be carriage return. Yeah, carriage feed. 13 in octal. \r, which is the carriage return / feed, in decimal is equal to 13. In octal, right, if we wanted to do this one, we would do equal to 0. This would add 8. We want to add 5 more, so 5. D. D. \t, the tab, right? Horizontal tab in decimal is 9. In octal, that would be equal to 0, 1, 1. Let's freaking go, dude. Let's freaking go, dude. All right, check our answers here. That one's good. That one's good. Nice. Let's go. Oh, we killing it right now. New Year's resolution. I don't have one yet. I have to think about it, honestly. I have to think about it. Okay, number 8. We're cruising here. Recall exercise 7, but give the equivalent hexadecimal escape. Okay. So hex is equal to 0x. So this one we need to get to 8. And we have 16 is our base. So this would be hex 8, just like that. Hex is equal to 0x. And this would say well, with hex, do you have to fill in the blank zeros for how many there might be? But can it be like technically infinite because it can go up to infinite numbers? It's not like a minimum or a maximum. So for 12, right, a hex is still base 16. So this would be 0x12. We don't ever get above 16 here. So it's just pretty simple. No? Am I? Oh, sorry, this is 10. This is 13, and this is 9. Right? Yeah, the hex values are just 9. The line feed, vertical tab. Carriage return is 13, which is 0D. Oh! Come on, Mike. I'm trolling. Okay, hold on. So remember, hex numbers only go 0 to 9, and then A through F for 10 through 15. So 13 in decimal, right, for the carriage return would be hex of 0x. 13 is, so 10 is A, 11 is B, 12 is C, 13 is D, right? So this would be D. Now, why do they put 0D? Because you have a minimum of... I'm not sure. And then 9 would be 0x9. But 10 would be 0xa, right? So let's take this. Oh. Now I had to add hex. Can I just put single letters for 13 and 10? So 8 is 0x8, 0xa, 0xd, xd, 0x9. Nice. Perfect. Nice. Number 9. Suppose that I and j are variables of type int. What is the type of the expression of I divided by j plus a? I don't think that did I not screenshot that hierarchy pyramid looking thing? Oh, that was not in this note. That was in the lecture video. So if we include a char into our expression, right, the division is going to take place first, just through order of operations. And then we're going to add the resulting value of this to a char. Now, does the addition of a char cause... Oh, here we go. So I believe that the char would be converted to type int, and we would return of a type int, because we're not saving back in a char. My guess would be, if I had to make a guess, which I do, the type of the return type of the expression I less than j plus quote a, where I and j are ints, would be also a... So the expression would return an int. The char would be promoted to type int during the arithmetic, and the resulting value remains int, as we are not saving or casting this value anywhere. I don't know. That's my guess, but what do you guys think? If you guys had to make a guess. I'm not super sure on this one. I'm making an educated guess. I and j are int. A is character with a 97 value. In C, char is automatically promoted to int in any arithmetic expression, so A becomes 97 for the arithmetic operation. The division of I less divided by j, both int, returns an integer, and the addition returns an integer. The result is type int. Even though A is started as a char, it was promoted. Okay. Okay. Nice. Number 10. SSLO, his New Year's resolution, blast Tom McDonald every day. Oh, and get a girlfriend until I get a girlfriend. Oh, the programmer dilemma. Get a girlfriend. That's honestly the hardest algorithm you've got to solve, is how to get a girlfriend, huh? Right? The key to it is get a girlfriend first and then learn programming, and then she's stuck with you once you realize that you're a nerd, and you know that's what I did. All right, cool. Number 10. Suppose that I is an int and j is a variable of long and k is a variable of unsigned int. Okay, k is a variable of long. Just be long. If I is an int j is a f equals to a float, and d is a, j equals a long, and k equals to unsigned int, the expression I plus int j. So we cast j to an integer, right, from a long. Okay, got you. So we have int plus int times unsigned int. So if you have an unsigned int being multiplied against an integer, okay. So int is the lowest form besides char. Then unsigned int comes next. Where's my values? Unsigned int is 0 to 4 million. Sorry, 4 billion. Okay, so this one then is pretty easy. Returns an unsigned int. When an int and unsigned int are combined in arithmetic, the int is converted to unsigned int. Unsigned int. Okay, nice. 11. Suppose that I is a variable of type int, f is a variable of type float. So here we go. So I equals to int, f is equal to a float, and d is equal to a double. Right? We have I times f less than divided by d. This returns, what does this return? So we have an integer times a float divided by a double. Okay, so the float is promoted to double, and the integer is promoted to a double. Well, this probably would happen first. So it would be promoted to a float first, and then that float value is promoted to a double. So this would return a double. I would be promoted to float, and the value of I times f would be promoted to double. Perfect. Int times float is promoted to float, and then float divided by double is promoted to double. So we'll say I is promoted to float. The result of I times f which is promoted to okay, nice. Almost there, you guys, almost there. 12. Suppose that variable I is an int, f is equal to a float, and d is equal to a double. We want to evaluate the return of d equals to I plus f. Okay, explain what conversions take place during the execution of the following statement. Okay, so I is an int. I is promoted to a float to compute I plus f. This value is intrinsically, I don't know how to spell that, intrinsically converted to a double upon assignment. Oh, let's check this one. Int float double. I is promoted to float to match the type of f, so the addition of float plus float returns a float. Assignment to d, the result of I plus f is a float, so assigning to d, float is converted to double automatically. Your wording intrinsically converted to double upon assignment is perfect. Oh, let's go. Let's go. It's gassing me up here, huh? 13. Assume that the program contains the following declarations. Char c equals to \1. Short s is 2. Int I equals 3. Okay, so A. Give the value and the type of each expression listed below. So C times I \1. What is \1? Char C equals to quote \1 quote. Start of header. Just an ASCII value of 1. So this would be give the value and the type of the expression. So 1 times -3, so it would be int -3. S plus M, short plus long, be a long 7. F divided by C, so float divided by character would be float. D divided by S, so double divided by short What, 3.75? Right? E, F minus D, float minus a double. This one's a little tricky. I'm not sure. F, int F. This will just give int 6. Okay, what would F minus D give? A float minus a double. What's a float minus a double? Would we keep the double but keep the float value but increase it to a double? Yeah. Promote it to double. Sorry, I was thinking long for some reason. Double. This is F minus D. Oh, can you get negative ones? Would this error out? Let's get some feedback on this one. I'm not really sure. I like times C. Oh no. Hold on. This is quote \1. -3 and return an int. Great. S plus M, short plus a long, would promote the short to an int and give you a long back of 7. Great. I divided by 7, which is an int divided by a short. The short would be promoted to an int, returning you back. I think I had I divided by S. No. Ugh. Let's do F divided by C. Float over float, 6.5. Great. And what about D over S? So short is promoted to an int with a value of 2. D is a double. The int is converted to a double. So double divided by double returns a double with a value of 3.75. Perfect. Now this is the tricky one. F less than D. Can we go negative in the float value? and float is promoted to double to match. The operation is double less than double, which is -1. Yes. So the double Syndev, I love pie. Hey, how's it going? I'm at a loss for how to design a view for searching a read-only file share. I'm at a loss for how to design a view for searching a read-only file share for electronic applications. Good, man. You should go check out a couple of streams back. We worked on my Pocket Farm app. Like you can check back on my VODs on YouTube or whatever. And we have been building that in React. We've got a pretty good kind of a home page, hero page, sign-in page, and create account page. And we're starting to work on the dashboard page, pretty much using about 98% of original code and just getting a little bit of help here and there from some online resources and whatnot. But all the designs and everything is all my own. I've been planning and laying everything out, and making and whatnot, and it's been really fun so far. It looks really, really nice. I'll have to bring that up here once we finish these problems. Okay, and then let's do int f, which would just give us to 6. Perfect. Awesome. Does the following statement, 14. Does the following statement always compute the fractional part of f correctly, assuming that f and frac part are float variables? Okay. So frac part is a float and f is a float. We're going to subtract the f converted to an integer, so it drops the value, basically floors it by 1. And so let's see here. Let's go to our notes. Let me look up. So floats have 32 bits. So why wouldn't this compute it correctly? Let's say that the values what do you guys think? Taking the float and reducing it by the integer of the float would remove the base values, leaving the decimals. And those values are being saved in frac part. Now, what if the value is so small that it's rounded, right? Because it's a double? I think that might be it. So let's copy this. If the subtraction, if the difference is so small, the float precision may round to 0. We would need greater precision. Yeah, I think this is it. to compute super small fractions, we would need type double, right? If f and frac part are floats. This is my reasoning. How does it sound? Is basically correct. You're touching upon the point of floating point precision limitations. So the floating point precision issue arises. Floats have about 7 decimal digits of precision. Very small differences, like with, hundreds of thousands of a decimal, may not be represented exactly. Subtracting a large float from slightly larger float can result in a rounding to 0. Any difference that exceeds the precision limits of the float. Right. If you want, I can draw a diagram. Cool. So would we need double? Yes. If you care about very small fractional differences, using double is safer. Okay, nice. I didn't think we were going to get that one. That was nice. I'm glad we were able to sit there, kind of think about it for a little bit, and like say, I really wonder what's actually going on in that, and deduce what was going on and think back to our notes, and like a light bulb, we got it. It came back to us. That's really awesome. Cool. 15. Last one, guys. Last one. Thanks so much for being here. If you guys have enjoyed the practice problems and see, if you guys drop a like on the stream. If you're not subscribed, if you could just subscribe, it's completely free. Got a lot of great resources here on the channel and in my Discord and my GitHub, all for free. Everything's for free, guys. I haven't yet, opened up a membership thing for exclusive stuff. I've been thinking about it, but honestly, I just don't have the time to really dedicate to making exclusive stuff for like channel members. I would want it to be worth the while, and so I just don't feel just with lack of time with my time right now to do that. So free it is right now. Awesome. Thanks so much for being here. Okay, 15. Use typedef to create types named int8, int16, and int32. Define the types so that they represent 8-bit, 16-bit, and 32-bit integers on your machine. Okay. So if we include that h header file, good function here. Okay, so we need to find type def int 8, which is going to be equal to something int 16 and int 32. So let's go back to our notes here. Okay, so if I remember right, on my machine, which is a 64-bit machine, an 8-bit value would be what? Just a char? Right? 1 byte? A char? 16 bits, or 2 bytes. Is this not an int? And then is a 32-bit value, is this not a float? A char is only 8 bits, is 1 byte, because we only need to represent the values of -127 to 128. Or what, maybe something like that. An int on a 64-bit machine is represented in 2 bytes, which is 16 bits. And then a float has 4 bytes, which is 32 bits, right? Let's think here. Let's go here. Trying to figure this one out. I am on a 64-bit machine. We haven't learned about malloc or anything. The code is trying to create type def, but the syntax is incorrect in C. Okay. Okay, so it's not an equal sign, sorry. Oh, and then you put type def char int 8. Okay, so the name comes after the declaration of the variable, like you would for a variable. So it's the same for defining a variable. You just preface with type def. Okay. That makes sense. That does make sense. Okay, so then let me give it this. This is now legal in C, which actually means char is always 1 byte, often used as 8-bit type. So this makes sense for int 8 alias. On a 64-bit machine, int is usually 32 bits, not 16. Oh, because it's a 32-bit integer, not a float, so we wouldn't want to do that. So let's go ahead. I didn't know we could do this. We did learn about this at the very end, right? We learned about the standard int.h to define our own underscore t to get access to these underscore t types, which are just implemented as macros for your type of architecture, right? So what we would do is do the standard int.h, and then this could be an int, 8 underscore t. Right, and then this would be int 16 underscore t. This would be int 32 underscore t. So if we do this, let's get some feedback here. This version is perfect. You're not using this. Okay, cool. All right. Sweet, you guys. Thanks so much for being here and joining me. That was a lot. We did, 2 hours and 11 minutes of practice problems here, 15 of them. Honestly, every time I do this, I think I'm gonna move a lot faster than I actually do. But it really doesn't matter at the end of the day. It's not like I'm got like a deadline or like I'm taking a test on this stuff in like a week or something. It really doesn't matter. It kind of feels like I need to go fast, but I really don't. So like I can really go as slow as I want to make the material absorb, which is honestly the better way of going about it. So I appreciate you guys being here and hanging out with me. As I work through these problems and really try my best to understand them, get examples, write them down for you guys. You guys can get access to the problems that we did today on my GitHub, link down below, for free. It's just in a repo that you can get. I'll add them up right now. Git commit. We'll say complete chapter 7 exercises. Cool, they're up for you guys. So go ahead and take a peek at those. We completed 15 exercises here in chapter 7, so super awesome. That was a lot of fun and a lot of practice. Getting more, honestly, I feel a lot better about hex and octal numbers now. It's crazy what a little bit of just repetition and a little bit of effort and actually trying to convert a couple of numbers will do for you in giving you some actual understanding of what they are. So understanding that octal numbers have that leading 0 with only 0 through 7 in there, with hex numbers having 0x, with 0 through 9, A through F, with base 16 in hex and base 8 in octal. Yeah, and I'm just getting a lot more, like a couple of LeetCode problems we did a while back when we had to do base conversions. I was really struggling because I just didn't really understand what I was doing, and how these kind of magnitudes were derived. And now I kind of actually understand. It's really straightforward. So I'm super excited to continue on, and I feel like I'm kind of getting the training wheels taken off here as we get more and more information. I'm definitely going to need to get more practice though with the conversion specifiers for the print statements for like all like these different types. Just a lot of like little acronyms or little like characters that you have to remember for inserting the values into the prints. And so I'm going to need to definitely get some practice with that. But I appreciate you guys being here and joining with me. This was the exercises at the end of chapter 7 of C Programming: A Modern Approach by K.N. King. If you want access to the book, I have a link of it in my Discord. There's also links just online you can find to read and pick up. Thanks so much for being here, and I'll see you guys tomorrow. Bye, guys.